Children, now what we are going to do is we are going to understand multiplication of matrices. So as in case of addition and subtraction, we did mention that there is some kind of compatibility test. That means so and so is necessary for we to go for addition and subtraction. What was it? Order should be the same. Likewise, multiplication of matrices, again we need to have some kind of compatibility. So what is compatibility for multiplication of matrices? Let's read it. Two matrices A and B can be multiplied together to get the product matrix AB. When A and B gets multiplied, we eventually get AB. If and only if, mind you, if and only if the number of columns in matrix A, which is always on the left hand side, is equal to the number of rows in matrix B, which is on the right hand side. So those who are still finding it difficult, let's understand it by writing it in this fashion. Picture will be more clear. So what the compatibility test says, that if I have matrix A, but natural matrix A, so some kind of order will be there. So we are presenting matrix A with the order m into n. We are presenting matrix A of the order m into n. So what is the number of columns in matrix A? N. Now I need to multiply matrix A with matrix B. So matrix A is getting multiplied with matrix B to get the resultant matrix AB. But again there has to be some kind of order. Now as per the compatibility test, it says that the number of columns in matrix A should be the same as number of rows in matrix B. So it has to be n into P. So now why P? Our requirement is number of columns in matrix A should match with the number of rows. I hope my children remember that this stands for rows. First one rows, second one column, rows and column. So the number of columns in matrix A, if and if only if matches with the number of rows with number of columns in matrix A matches with number of rows in matrix B, then and then only we'll have product matrix AB. Then and then only we'll have a product matrix AB, or one can say C also, or one can say A into B, which gives us C, or one can say A into B, which gives us AB. Are you getting me? Can you check it out? Number of columns in matrix A is n, number of rows in matrix B is also n. If this thing matches, then and then only, children, we are supposed to go for matrix multiplication. Otherwise, we cannot multiply two matrices. No, we cannot multiply two matrix. So what could be the resultant matrix will be having an order? If that question is there in your mind, that what could be the resultant matrix will have an order? Answer is very simple. What is left from here? M. What is left from here? P. Answer is M into P. As simple as that. You can say in your language, though we don't say in this way, but in your language you can say and then nullify what we are left with. We are left with M into P. So what should be the order of matrix AB, which is the resultant of A into B? Right? Order will be M into P. So what is the condition? Two matrices A and B can be multiplied together to get the product matrix AB if and only if the number of columns in A on the left hand side, but naturally this is on the left hand side, this is on the right hand side, is equal to the number of rows in matrix B. Both should be the same. So let's take a simple matrix. If I have A of the order 2 by 2, if I have matrix B of the order 2 by 3, are they matching? The number of columns in A and number of rows in matrix B? Absolutely. What could be the resultant matrix C? The resultant matrix C will be 2 by 3. As simple as that. Resultant matrix C will be 2 by 3. We take one more. Say matrix P of the order 3 by 2 into matrix Q of the order 2 by 3. What shall be the resultant matrix? Resultant matrix will be R. First of all, we'll check, are they same? Indeed. So the resultant matrix will be of the order 3 by 3. Last one. What if I have matrix M of the order 5 into 4? What I have matrix N of the order 3 into 4? Will I be able to multiply? Answer is clear cut, no. Why? Columns in matrix M, rows in matrix N doesn't match. We cannot multiply. So we can say cannot multiply or cannot be multiplied. cannot be multiplied. Right, children? That's what the compatibility test of multiplication for matrices is.